the class. One second. So we also looked at role of 1 in our number system, especially in the context of rational numbers. Then we looked at negative of a number. We understood some additive inverse, logic of additive inverse, reciprocal. Then we understood multiplicative inverse. If we have A by B, what is the multiplicative inverse of A by B? It will be B by A, because product should give us 1. Okay. Then we went ahead, we understood rational numbers and irrational numbers. When we are defining rational and irrational, most of you are struggling in defining an irrational number. Then we talked about, first we understood what are natural numbers, then whole numbers, then negative natural numbers, which we call them as negative integers, and all negative integers plus whole numbers giving you the entire set, right? So we understood real numbers. Then we went ahead and we talked about how number system looks like. That is, a number system is a combination of your real numbers and your imaginary numbers. This is not part of our syllabus at this point in time in your career, but we looked at rational number and we said a rational number is of the form P by Q, where Q not equal to 0, P by Q belongs to set. Then we also understood irrational numbers, wherein real numbers, we said real numbers that are not rational are known as irrational numbers. That's where we stopped in our last class. Okay, so did we do anything further? Not really. So in other terms, numbers, the real numbers that are not rational. What do you mean by real numbers that are not rational? The real numbers that are not rational means a number that cannot be put in the form of P by Q. The real numbers that cannot be put in the form of P by Q. If you cannot put them in the form of P by Q, then such numbers are known as irrational numbers. Okay, so that's what we learned in the last class. So let's continue from there. And we have loads of problems to solve today. So we'll not spend much of time on, easy concepts, which I think that most of you know or already know. I'll just skim through them. So if anyone feels that, no, sir, I need some help on that, please stop me. Don't hesitate to stop me wherever you think you need some help. Does that make sense? If yes, mention yes in your chat box.
Yes, sir, got it.
Brilliant. Okay, so because I almost have 20 plus questions to discuss today. Okay, yeah, good. That's nice. Let's get on. So, can anyone tell me? You might have learned about, in your previous class when you were discussing rational numbers. When we were discussing decimals also. In rational numbers, we learned about something called recurring and non-recurring, recurring, terminating. So can anyone share what are they? Can anyone explain me explaining rational numbers in the context of recurring, non-recurring, recurring, terminating, recurring, non-terminating? Anyone who wants to share their knowledge?
The numbers which
yeah,
go after the decimal point, like continuous without stopping anywhere.
Example?
2 by 3.
Okay, very good. Let's take 2 by 3 for a moment. Good. So what is 2 by 3? 2 by 3 is, if you calculate the value of 2 by 3, you can see it is 0.6666666 and so on. So what happens?
It continuously goes on without stopping, so we use bar in place of it.
Okay, we use bar in place of it. But what do we call this 0.666666 bar? Is it recurring or non-recurring?
Recurring.
Is it terminating or non-terminating?
Terminating.
Is it terminating? No, it is not. It's not terminating. So, so basically students make these mistakes. They don't understand the definition. Let's understand it. Good evening, Ritu. Okay, so let's quickly understand what do you mean by terminating and what do you mean by non-terminating. Okay, first let's understand that. So here in this case, 0.666666, if you keep on writing it, it is not terminating, it is going on. So that's whenever it's going on, that's the reason it's called non-terminating. Okay, this is called non-terminating. Okay, so because it is not terminating, it goes on and on and on and on and on. It's a different story that we write this as 0.6 bar. We'll understand that later. When some number is repeating, only the same number is repeating. Therefore, we call this as 0.6 bar. We'll come to these bars later on. Okay, so they are written as 0.6 bar. Whereas if I take a number like say 1 by 4. Now 1 by 4, you know if you calculate it is 0.25. If you calculate say 3 by 4, you know it is 0.75. So here if you look at, so is this this decimal value, is it a terminating decimal value or non-terminating? It's terminating because it's ending, it's defined. So whenever it is defined, it is terminating. So we call such decimals as terminating decimals, right? Terminating. So they are terminating somewhere. So here, because they are continuously going, they are called non-terminating. Okay, so that's the difference between terminating and non-terminating. So what is recurring and non-recurring? Anyone? So we understood terminating and non-terminating.
Yeah. Recurring is after the decimal point, one number or a particular set of numbers repeat themselves again and again, and non-recurring numbers can be non-terminating as well, because non-recurring numbers are numbers which are different. The same numbers don't repeat themselves.
So are you saying that now 0.7 is non-recurring? So are you saying that it is non-terminating also?
No. I mean, like, a lot of people think that non-recurring, I have had this confusion previously, that non-recurring are non-terminating. Are terminating, but then that, okay, wait.
Okay.
So,
I understood your point, Kavya. Don't worry. I understood. Good. So you understood the logic. Maybe you put it in a, I mean, not in a wrong way. I would say you got too confused when you're explaining, but that's fine. I understand. So coming to recurring and non-recurring. So let's look at a couple of examples. So if we have something like 1 by 7. So you know 1 by 7, if you calculate 1 by 7, it comes like this, 0.142857, 142857, 142857. It keeps on coming like that. If you want to calculate, you can use your mathematics. 1 by 7. You know how to divide, right? So you know if you divide, how do you do this? So you have 7, you have 1, you put decimal and you put a 0 here. 7 ones are 7, so you get 3 as the remainder. So then once again you put a 0. 7 goes how many times? 7 fours are 28. So you got 2 there. You put another 0. So 7 how many times? 7 threes are. So sorry, 7 twos are 14. So 1 4 2 is 7 twos are 14. Once again you get 6. You put a 0 there. You keep on doing this exercise. You'll realize you get 142857, 142857, 142857. It is like keeps on coming. No problem, Arjun. No problem at all. We just revised and we have just started now. So basically, if you look at 142857, 142857, 142857. So even here in this case of 2 by 3, if you can see 6, 6, 6, 6, 6, 6, 6, it's non-terminating, but 6 is repeating. It is recurring. Your 6 is recurring here. In this case, 6 is recurring. Here in this case, that's the reason we write it as 0.6 bar. Now in 1 by 7, we write this as 0.142857. We put a bar here. So when we have something that is recurring, so it is recurring. So whenever if it is recurring, and if it is even if it is non-terminating. So we always say that not. So can I say that 0.142857 because this is a infinite? It's non-terminating. It's non-terminating. Is this terminating or non-terminating? This particular, is it terminating or non-terminating? 0.142857.
Non-terminating.
It's non-terminating. So it's non-terminating, but it is recurring. When I say recurring, the same numbers are repeating. So whenever you have recurring and non-terminating, recurring and non-terminating. So even if it's a non-terminating, so it's not terminated. So this is terminated anyways, you know, 0.25, 1 by 4, it's a rational number. 0.75, it's 3 by 4. So if a number, if a decimal is terminating, it's anyways a rational number. See guys, please understand this logically. If you don't understand, you go and ask anyone, you know, you talk to a 10th class kid or you talk to a 11th class kid, ask him what a rational number is. He'll get confused. You ask him, tell me in the context of recurring and terminating, recurring and non-terminating. He'll get confused. He'll not tell you the definition because they remember in school. They don't understand all the time. So the kids who understand, they actually understand mathematics. They don't understand, they will never understand. So it's very important for you to understand when I'm saying terminating, that means 0.75 is terminating, it's ending. So there is a defined value. If it's defined value, terminating, it's a rational number. So here, if you look at recurring and non-terminating. So here, here in this case also it's non-terminating. So it goes on and on and on and on and on, non-terminating. Because it is defined, it is same thing, recurring. The same number is recurring. So such a number can also be written as, you know, that value is equal to 2 by 3. So that means that such numbers can be put in the form of 2 by 3, which is in the form of P by Q. Because it's in the form of P by Q, that's the reason it's a rational number. So because it's fitting the definition of rational number. So the point I'm trying to tell you is recurring means the same numbers are repeating, and non-terminating. So even if it doesn't terminate, it's a non-terminating number, still such a number can always be put in the form of P by Q. Therefore, it is a rational number. Therefore, it's a rational number. You get this? Everyone gets this? Now that leads us to understand what is an irrational number. So in this context, anything which is non-recurring and non-terminating. So now that leads us to non-recurring. Non-recurring, so it's not repeating. Non-recurring and non-terminating. So non-recurring and non-terminating decimals. Non-terminating decimals cannot be, they are not in the form of P by Q. Therefore, they are irrational numbers. That's the reason they are irrational numbers.